In the previous video, we had learned about the electronic configuration of elements and the periodic table with respect to periods. In this video, we will be talking about groups. First of all, the vertical column in the periodic table is called a group, and each group has the same configuration of valence shell, but they vary with respect to the principal quantum number. For example, if you talk about fluorine, chlorine, bromine, iodine, all of these are considered halogens, and all of them have the outermost electronic configuration as Ns2 and Np5. But they will vary with respect to the principal quantum number. So for in the outermost shell. So for fluorine, it will be 2s2, 2p5. Chlorine will be 3s2, 3p5. Bromine will be 4s2, 4p5. And iodine will be 5s2, 5p5. And because each of these groups have similarity in, or rather their outer electronic configuration is the same, generally a particular group will show similarity in their chemical as well as certain physical properties. So there are 18 groups in the periodic table, and each group is also called a family. So you have 1 to 18. Previously, they had also used Roman numerals, and that had 1 to 8, A and B. So, but due to the suggestions by the IUPAC, the long form of the periodic table has only the numbered system. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, anyways, till 18. But if you notice in your textbooks as well, that is the NCERT textbook, you'll notice that the periodic table has Roman numerals as well, and that goes from 1 to 8, A and B. Now, the properties of elements, they're similar in each group, are similar to each other because they have the same number of electrons in their valence. Oh, I'm so sorry, it's supposed to be valence shell. So the electronic configuration in the end of the day is the one which drives the various properties of all of these elements, right from, for example, lithium, sodium, potassium, rubidium, and cesium and francium. All of these elements have one electron in their outermost shell, and to gain stable electronic configuration, they lose an electron. So there is a similarity in properties between all of these elements, whereas fluorine, all the halogens, that is in group 17, they have a tendency to gain an electron. For the stability in the electronic configuration, that is to reach the noble gas configuration. So as we know, first of all, it's the electronic configuration which drives the properties of a particular element. When we talk about periods, each period you have a new principal quantum number getting added. Whereas in groups, the outermost electronic configuration, that is the valence shell, there is a similarity in the configuration for each group. With that, I think we finish up with the electronic configuration of the periodic table with respect to its groups and periods. In the next video, we will be learning about the individual blocks in the periodic table. So do check it out.